So today we're going to talk about our day 6 notes, which is interval notation, inequalities, and on this first page of your notes there is a grid with lots of different ways to represent inequalities. You have inequality notation in the first column, represented on a number line graph in the second column, and the last one is interval notation. So take a minute and look at the following examples listed. Jot down any observations or connections that you notice, things you may have remembered about inequalities or things that you're recognizing now based on these examples, and answer some of those observations in the question that follows. Okay, and take a look at some of the connections I have recorded on my notes. Number 1, the brackets are always represented with a closed circle on the number line, and that means that they are or equal to in terms of the inequality sign. If it's less than or equal to, greater than or equal to, we color in that number on the number line with a closed circle, and in interval notation it gets a bracket. Whereas the parentheses in that interval notation are represented with an open circle on the number line, and that's where it would just say strictly greater than or strictly less than, so we're not including it. Another place that you'll see the parentheses in use is when it goes all the way to infinity, and that's where I have an arrow all the way to the right or all the way to the left. Another observation is that union symbol within our interval notation means or. And whenever I'm looking at interval notation, I'm recognizing that it's being read from left to right. So let's take a look at filling in the blanks on some of these examples. Number 1 is done for us. Let's take a look at number 2. It says x is less than 2. So on my number line, I'm going to put my circle on 2. I'm going to leave it open because it's not including it. It's just less than. And anything less than 2 is going to be my numbers to the left, going on forever and ever, hence the arrow. So when I go to write this in interval notation, I start from the left. So as far left as I can go is negative infinity. Up until 2 would represent all of the numbers within my solution set. I put a parentheses on 2 because we're not including it. It's just less than. And infinities always get a parentheses. It's not an actual number that we can achieve and get to. It just goes on and on and on and on and on. For number 3, x is greater than or equal to 0. So I'm going to put a circle on my 0. This time I'm going to color it in because I do want to equal the 0 as well as, in this case, be greater than. So I'm going to pick all my numbers that are larger than 0 forever and ever. In interval notation, again, always write it from left to right. So I'm starting at 0 and I'm going forever towards infinity. Infinity always gets a parenthesis. It's not a physical number we can include. This time the 0 gets a bracket to represent the fact that it is included in our solution set. Number 5, I'm going to skip to. This is now a compound inequality. X is being set between two numbers, so it's not going forever in either direction. This is read x is greater than negative 3, so open circle on the negative 3, greater than that number up until 1, because then the inequality reads that it's less than or equal to, color it in, 1. So now I'm only looking at those numbers strictly between negative 3 and 1. 1 gets the bracket, negative 3 gets a parentheses. Taking a look at number 7, just skipping to a couple of different ones here. Number 7 says x is less than 2 or x is greater than or equal to 0. So now I have an or, I have two separate chunks of numbers that would work. X is less than negative 2, open circle on the negative 2 and go everything less than that. Or greater than or equal to, so now a closed circle on 0, and then greater than means everything bigger to the right of that number. And now both of these would work and be acceptable answers in terms of our x values. So in interval notation, I need 2 intervals. So again, left to right, you're going to start all the way as far left, which is negative infinity, up until negative 2 parentheses, because I'm not including it. Here's where that union comes in. You're saying or all these other numbers which start at 0, including 0, so there's a bracket, and then forever towards the right, so infinity. Next, we're going to look at number 10. We are given interval notation. negative infinity to negative 3, union 2 to infinity, parentheses for everything. I'm going to draw it out first. So I'm starting left to right. So negative infinity would mean my arrow is going to go as far left as we possibly can and include all of those numbers up until negative 3. Open circle because it is a parentheses on the negative 3, so we're not including that number in our set. Union would mean or, so either any of those numbers work, or starting up at 2, again, open circle for the parentheses, and then going forever towards my positive infinity. If I was to write that as an inequality, I would just simply say my first one, which is x is less than negative 3, or, with the word or there, x is greater than 2. Go ahead and try number 11 and answer the interval notation on the end puzzle. So there are a lot of other examples in your note packet for interval notation. We'll use some more of those in class tomorrow. Flip ahead to the next page where it says solving inequalities in one variable. And we're going to go ahead and start with this first box on the left and solve the inequality that's listed. So just like we were solving our algebraic equations and simplifying expressions, I'm going to go ahead and apply those properties. I'm going to distribute my 3 into that x minus 2. I'm going to distribute my 4, and I'm going to distribute my negative 2. Again, always be careful when you're distributing negatives. Combine my like terms, so I have 3x minus 1 is greater than 2x minus 6. Continue combining from side to side. I'm going to subtract an x over, or the 2x over, and then I'm going to add my 1. So I get x is greater than negative 5. So you solve an inequality just like as if it wasn't an equation. Written in interval notation, so greater than negative 5 would mean everything from negative 5 but not including it, so parentheses, and then greater than all the way to infinity. On a number line, I would open circle my negative 5 and then shade in everything to the right that is greater than negative 5. You're going to go ahead and try the next box to the right. Enter your answer on Edpuzzle. So now we're going to look at this bottom box, and just remember that solutions to inequalities are all the values of a variable that make that statement true. So they've worked out this one for you here, negative 3 times x minus 2 greater than or equal to 4 times 2 minus x plus 3x. And as you can tell, all the algebra looks good. We get down to x is greater than or equal to negative 1. If I were to graph that, so this interval notation, negative 1 to infinity, including the negative 1 means a bracket, and then greater than means to the right. All of my values that are bigger than negative 1 should be my solution set. So then to the right it says choose a value from your solution interval. Again, any of those numbers should work, right? So I'm going to pick, how about 2? X equals 2, it's shaded in, it's greater than negative 1, it should work. And I'm going to substitute it into the original statement to just double check my work here. So I have negative 3 times 2 minus 2, which is greater than or equal to 4 times 2 minus 2 again for x, plus 3 times, again, 2. So I get negative 3 times 0, greater than or equal to 4 times 0, plus 6. Anything times 0 is 0. 0 plus 6 is 6, and it says 0 is greater than or equal to 6. Well, then I realize we've got a problem, right? That's not true. What the heck happened here? So the issue with this one is now our equation was wrong. What did we do on the left that somehow got us the wrong answer? Well, if you remember from inequalities, there is a little trick we've got to be careful with. Right here, when I divided my two sides by a negative 2, that inequality has to flip. Let's think for a minute in terms of just regular numbers. If I told you that 2 was less than 3, is negative 2 also less than negative 3? No. So in order to make that inequality true, the minute you flip and you essentially are dividing by a -1 here within an inequality, that inequality sign has to change directions. So now -2 is actually greater than a -3. So we're going to go ahead and put that rule on the next page. Important rule when solving inequalities. When you are dividing, or you could think about this as also multiplying, because I could have multiplied by a -1 on both sides. So whenever you divide or you multiply by a negative value, you must flip the inequality sign. Okay, we're going to go ahead and try the box on the far right, where it starts with 6 minus 2x over 4 plus x is less than x minus 2. So for whatever reason, fractions just tend to throw people off, so let's go over the one with a fraction. I would isolate the fraction before you try to get rid of it. I just think that makes for a nicer setup. So I'm going to go ahead and subtract x from both sides. So I'm just left with the fraction part, 6 minus 2x over 4, which is less than, well, I subtracted that x away. X minus x is 0, so those wiped out. Minus 2 is all I'm left with. Now the best way to get rid of a fraction is just to multiply by whatever is on the denominator. So if I multiply this left side of my equation by a 4, 4 times 4 is just 1, and I'm left with 6 minus 2x. Well, whatever I do to one side, I also have to do to the other side, so I'm going to also multiply by a 4 on the right, and I get -8. -2x is less than, subtract your 6, -14. And then I'm going to divide by a -2. So again, whenever this happens, when you're dividing an inequality by a negative, we have to flip our sign. -14 divided by -2 turns into a +7, and we get x is greater than 7. Pay attention to the directions. It does ask us to write the solutions in interval notation. So greater than 7 means starting at 7 but not including it, so that's a parentheses, and then all of my positive numbers that come after that. And again, infinity always gets a parentheses. It's not an actual number I can include. We'll also go ahead and do this bottom left box together. -6 less than 2 times x minus 1 less than or equal to 8. So this is a compound inequality where you just have to get that x by itself in the middle. But in order to do that, I have to manipulate both sides of this inequality. So you can either distribute the 2 first, or you could divide the 2. Doesn't really matter. I would say since both left and right sides are divisible by 2, it wouldn't be a bad idea. But for the sake of future examples, I would probably just distribute my 2 in first. Let's simplify and then start to move things around. So I get 2x minus 2 inside there. To get x by itself, I need to move the 2. So I'm going to go ahead and add 2. Well, I have to do that to the right side as well as the left side. So now I have a -4 less than 2x less than or equal to 10. To get x by itself, I have to divide by 2. Same thing, if I'm going to divide by 2, I have to divide all 3 sides by 2. And I get -2 is less than x, which is less than or equal to 5. Once again, in interval notation, my final answer is saying all of my numbers that are greater than 2, but not including it, all the way up until 5, including that because of the interval notation. Because of the or not equal to symbol. So it gets a bracket in interval notation. All right, let's look at the note at the bottom of this page. It says, do you remember when the variables completely canceled out of an equation? With the statement of 0 equals 0, that means we had an infinite number of solutions. Or maybe it said 0 equaled 5, which just doesn't make sense, so there was no solution. Well, what happens when our variables cancel out in an inequality? So let's try that first box on the left on now your next page here. goes solve the inequality. So I'm going to go ahead and same thing, distribute my 3. I get 3x minus 6 minus x greater than, distribute my 2, 2x minus 6 minus 5. Combine my like terms, 2x minus 6 greater than 2x minus 11. And now here's my issue. My x's are canceling out again. And I'm just left with negative 6 being greater than negative 11. In a similar sense, when I have no more variables, I look at the inequality that I'm left with and I ask myself, is this true? Does negative 6 actually, or is it actually greater than negative 11? And this is true. It is greater than negative 11. So in this sense, I know that I have all real numbers that would work. Or if you want to say in interval notation, negative infinity to positive infinity. Every single real number would work. How about on the second one? Go ahead and try that and then determine what you think your final answer should be. Take a look at my work there. The 2x's again canceled out, and the inequality we were left with, negative 6 being greater than 5, is now a false inequality. That does not make sense. That will never work. So in these scenarios, we have no solution. We're going to go ahead and finish the solving compound inequalities together in class tomorrow.